Welcome back to the deep dive. We are skipping the small talk today because we have a bone to pick.
Oh, with what?
With the way most of us interact with our data, we treat our databases like I don't know, a fast food drive-through.
Ah, I like that.
You know, you pull up, you mumble something into the speaker, and you just hope the right bag of food comes out at the window.
That is uncomfortably accurate. And, most of the time, we kind of get away with it.
We do. But today we're looking at the read operation, specifically the select statement in SQL.
The R in Sura.
Right, the R in CRUD. And the mission isn't just to, learn the syntax. If you're listening to this, you probably know how to write a basic query. The mission is to stop being a lazy asker.
Lazy asker is a very polite way to put it.
Yeah.
We're really talking about the difference between just data retrieval and an actual data strategy.
A strategy.
Because in the world of high-performance applications, how you ask for the data is just as important as the data itself.
Exactly. We're basing this discussion on the core mechanics of SQL. But let's be real, these concepts haunt you, whether you're in Postgres, MySQL, or
Oracle, anywhere. It's universal.
It's the only one of the four CR read operations where being inefficient can silently kill your entire application's performance without throwing a single error.
That's the key. If you break an update, the app crashes immediately. You know you failed.
Right. You get feedback.
But if you write a sloppy read query, a sloppy select, the app still works. It just gets slower and slower. It costs you more in bandwidth until one day it just hangs.
So let's audit our habits, starting with, I think, the most common crime in the SQL world. The wildcard.
The asterisk.
Selected. The star. It's the developer's comfort blanket.
It is. You're debugging. You just want to see what's in the users table, so you bang out selects from users. It's pure muscle memory.
For ad hoc debugging in your terminal?
Yeah.
Sure, go for it. But the documentation, and frankly, any senior engineer reviewing your code will tell you that select in production code is a trap.
And it's not just about being tidy, right? Not at all.
I used to think it was just about performance like don't fetch columns you don't need, which is true.
It is definitely true.
If you have a column storing a 5 megabyte image blob, and you pull that every time you just want the user's email address, you are just clogging your network pipe.
But that's the obvious performance hit. But there is a much more insidious risk. It's called schema evolution.
Okay, break that down.
Okay, imagine you write a Python script. It runs select on a table with 3 columns, name, date, and ID. Your code expects 3 items.
Right, it unpacks them into 3 variables.
It runs fine for a year. Then a DBA decides to add a 4th column, maybe last login, to that table.
The database is fine. It accepts the new column, no problem.
The database is fine, but your script,
It crashes.
it crashes.
Yeah.
Because it asked for everything, and everything just changed its definition. It received 4 values when it was hard-coded to handle 3.
So by using the wildcard, you tightly coupled your code to the database structure.
Precisely. If you had just typed select name, date, ID, that new column could have been added, and your code would not have even noticed.
That's the contract concept. You're signing a contract with the database saying, I don't care what else you have, just give me these specific things.
Exactly. It makes your application resilient to change.
So, rule 1.
Yeah.
No stars in production. Be explicit. Okay, now let's talk about filtering. The where clause.
The gatekeeper.
We aren't going to insult anyone's intelligence by explaining what less than or equals means.
We all know basic math.
But I want to talk about the hidden performance killers in the logic operators, specifically the choice between OR and IN.
Oh, this is a classic optimization win, a really good one.
So say I want to find users with ID 1, 5, or 10. The instinctive way to write that is where ID 1 or ID 5 or ID equals 10.
It works. It's totally valid SQL, but it's clunky.
And the documentation suggests using IN instead. Where ID in 1, 5, 10. Visually, it's cleaner, but is it actually faster?
Often, yes. And it depends on the database engine. But a long chain of OR statements can sometimes sort of confuse the query planner. It might evaluate each condition on its own.
Ah, okay.
IN, on the other hand, is treated as a set operation. The database sees that list and says, okay, I'm grabbing anything that matches this set. It's much easier to optimize, especially if that column is indexed.
So IN isn't just syntactic sugar, it's a hint to the database engine.
It's a very strong hint.
Okay, what about pattern matching? The like operator.
Like is powerful, but it's also dangerous. It lets you match partial strings.
Right, the source material points out you can match 1 or more characters, usually with the % sign as a wildcard. So where name like Smith% finds Smith, Smithers, Smithsonian.
Correct. But here is the gotcha that catches everyone. If you put that percentage sign at the beginning of the string like where name like present Smith,
No,
you have just nuked your performance.
just of the index.
Exactly. Think of a phone book. If I ask you to find everyone whose name starts with Esm, you can go right to the S section and find them instantly.
That's an index search.
Right. But if I ask you to find everyone whose name ends in Ifith,
Oh, I have to read every single name in the entire book.
you have to read the whole book. That's a full table scan. So while like is useful, you have to be aware that how you use it dictates whether the search takes milliseconds or, minutes.
This brings us to the elephant in the room, or maybe the ghost in the room. NELL.
Null paradox.
I feel like NELL is responsible for more logical bugs in reporting than any other single feature.
Without a doubt. And it all stems from a basic misunderstanding of what NLL actually is.
We want it to be 0, or an empty string, or just nothing.
But it's none of those things. In SQL, NLL represents unknown. It is a state of missing information.
The state.
And because it is unknown, it cannot equal anything. It also cannot not equal anything.
This is the part that breaks people's brains. If I have a table of users and I want to find everyone who is not 25 years old, I write where age 25.
And you get a list of everyone who is 26, 30, 40.
But I do not get the people who have NLL as their age. They just vanish.
They vanish, correct.
Yeah.
And that's the trap. Your logic says, if they aren't 25, show them to me.
Right.
But the database logic is, this person's age is unknown. Is unknown not equal to 25? Well, I don't know. It could be 25, it could be 50. Since the answer is unknown, I cannot return this row.
That is terrifying for data accuracy. If you're running a report on customers who haven't paid and the paid column is NLL for some new signups,
Your query might just exclude them entirely.
wow.
You drop records simply because you forgot that NLL fails all comparison tests. You have to handle it explicitly.
With IS NLL or is not NL.
Exactly. You have to specifically ask the database, show me the ones where the value is unknown.
It seems like a hassle, but I guess it's philosophical in a way. The database refuses to guess.
It refuses to lie. It's strictly sticking to three-valued logic: true, false, and unknown. If the result isn't explicitly true, you don't get the row.
Okay, let's move from filtering to organization, the unspecified order.
Yes. This is a concept that unnerves people, especially if they come from the world of Excel.
In Excel, if I type Steve in row 1, he stays in row 1. Simple.
In a database, a table is not a spreadsheet. It's more like a bag or a heap. When you stick data in, the database throws it wherever it has free space on the hard drive.
So if I run select name from users today, and I run it again tomorrow,
You might get the names back in a completely different order. There's no guarantee.
that feels chaotic.
It is, and it's by design. It's for speed. But it means that if your application relies on the data coming back in a specific order, say alphabetical, and you don't explicitly type order by name,
It's gambling.
you are gambling, and eventually you will lose. I've seen bugs where a latest news feed was showing articles from 3 years ago because the developer just assumed the database would return the newest stuff at the top.
It doesn't work that way.
Never works that way.
So order by isn't a nice-to-have feature for users. It's a structural requirement if you want any kind of consistency.
It's mandatory for consistency.
Now, speaking of sorting, what happens to our friend NL when we sort?
Ah, yes. If you sort a list of scores from high to low, where do the people who haven't taken the test yet go? Top or bottom?
SQL puts them at the beginning, right?
By default, yes. SQL treats NL as smaller than any other value. But that might not be what you want visually. You might want the unknowns buried at the bottom of the list.
And the documentation mentions you can control this with NL last.
Right. Order by score, desk NL's last. It's a small syntactical thing, but it creates a much better user experience than having a bunch of empty rows at the top of your leaderboard.
Moving on to the advanced controls, we have limit and offset. We all know these are for pagination, like showing page 1 of 10.
Right. Limit 10 gives you 10 rows. Offset 10 skips the first 10. Pretty straightforward.
But there's a performance implication here too, isn't there? If I say limit 10, offset 1,000.
You've just hit on a huge scaling pain point. The database still has to read and count through those first 1 million rows just to know where to start.
So it doesn't just jump to row 1,000,001.
No. So offset gets progressively slower the deeper you go into the data.
Meaning page 1 of your results loads instantly, page 10,000 takes 5 seconds.
Exactly. For really massive data sets, developers often switch to something called key set pagination, where you say, show me 10 rows where the ID is greater than the last ID I saw. But that's a whole other deep dive.
Right. So for most standard apps, limit and offset are your bread and butter.
They are.
Let's talk about group by versus having. This is a distinction that trips up a lot of people, especially during interviews.
It's all about the order of operations.
We know where filters individual rows. We know group by then squashes those rows into summaries like total sales per country.
Right, so imagine the pipeline. First, the database looks at the raw table. Then, where runs. It filters out all the trash rows you don't care about. Then the remaining rows are grouped together.
And that's where having comes in.
Exactly, having filters the groups. You cannot use where to say, show me countries with more than $10,000 in sales.
Why not?
Because at the where stage, the database doesn't know the total sales yet. It's still looking at individual transactions.
So where filters the input? Having filters the output of the grouping.
That is a perfect way to remember it, yes.
Okay, we've structured the query. We have our columns, our filters, our sorting. Now we have to get this data out of the database and into our code. The source uses Python as the example here.
This is the bridge, the interface between the two worlds.
And it introduces the concept of a cursor, which I have to admit always sounded a bit antiquated to me. Why do we need a cursor? Why can't I just say, get data?
Think of the database as a fire hose, a massive fire hose of data. And think of your Python script as a bucket.
Okay.
If you just open the valve wide open, you might overflow the bucket or, knock it right out of your hands. The cursor is the valve handle. It allows you to manage the flow of data, keeping track of where you are in the stream.
And we have two main ways to turn that handle, fetch_tone and fetch_all.
Right. Fetch_tone just retrieves a single row. It returns it as a tuple, a fixed, immutable list. Fetch_all. Well, it drinks the entire fire hose. It pulls every single matching row into your computer's memory as a list of tuples.
And this brings us to what the notes call the golden rule of filtering.
This is maybe the most important takeaway of this whole deep dive.
The rule is, filter in the database, not in the application.
Yes. 1,000 times yes. I see this pattern all the time with junior developers. They're comfortable in Python. They know how to write if statements and loops.
So they just grab everything.
They write select from logs, download a million rows into a Python list, and then write a loop to find the 5 errors they actually care about.
It works on their laptop with test data.
It works with 100 rows.
Yeah.
But in production, you just transferred gigabytes of data over the network, clogged up your server's RAM, holding a million rows you don't even need, and burned CPU cycles, iterating through all of them.
Whereas if you had just added where type error to your SQL query,
the database engine would have used its indexes, skipped the million boring rows, found the 5 errors in microseconds, and sent a tiny, tiny packet of data over the network.
it's about data gravity.
Push the logic down to where the data lives. Don't bring the mountain to Muhammad. Go to the mountain.
Or in this case, send a tiny SQL query to the mountain and ask it to throw down just the nuggets of gold you want.
Exactly. Database engines are literally built to do this. They have decades of optimization engineering behind them. Your Python loop does not. Trust the database.
So to recap the strategy here, we start by being specific, no wildcards. We use the right tools for filtering in instead of or, careful use of like. We handle NL explicitly because unknown is not false. We demand order with order by. And finally, we make the database do all the heavy lifting before we even pull the data into our card.
That is the manifesto of a solid back-end engineer.
It really changes the way you look at a simple select statement. It's not just a command, it's a request for truth.
And that brings me back to that philosophical point about NL.
The idea of unknown.
We live in a world, especially in tech, where we want binary answers. Yes or no, 1 or 0, pass or fail.
Right.
But NaOL is the database's way of having humility. It's the system saying, I don't know yet.
It's a valid state of existence.
It is. And as you design your applications and your queries, you should ask yourself, how does my system handle the unknown? Do I treat a missing value as a 0? Do I treat it as an error? Or do I respect it as a gap in our knowledge that just needs to be filled?
Wow. If you treat a missing test score as a 0, you fail the student. If you treat it as NULL, you simply acknowledge they haven't taken the test yet.
The distinction changes everything.
That is definitely something to chew on the next time you are staring at a blinking cursor.
Indeed.
Thank you for listening to this deep dive. Go fetch some data, but do it responsibly. We'll see you on the next one.